In this video, we are going to describe the two-break distance theorem. And now, we are going to speak about the two-break distance problem. Theorem, my point. So again, what does it mean to sort by two breaks? Remember that a genome is composed by areas that are shuffled in different organisms. And to sort a genome into another means to reproduce the shuffling of the other organism in the first one. So the question is, given a genome P, which two breaks should I apply to obtain a genome Q? So I have a breakpoint graph PQ, and how do I transform it into a breakpoint graph QQ? So I'm going to start from cycle PQ and I'm going to conclude in cycle QQ, and I remember that I know the cycle QQ is the maximum number of cycles that correspond to blocks QQ. As a consequence, I have to increase the initial cycle PQ of blocks PQ minus cycle PQ. So, a two break may change cycle PQ by, there are three different possibilities. The first one is that cycle PQ does not change. The second one is that cycle PQ increases of 1. And the second one is cycle PQ decreases by 1. So, each two break increases cycle by at most 1. We can have different cases. We can create a maximum of 2 new cycles. We could destroy at least one of the cycles. And this is the repetition of the previous example, showing that a two break can avoid to alter the number of cycles. A two break can increase of 1 the number of cycles, or it can decrease of 1 the number of cycles. What is the two break distance theorem? The two break distance theorem says that a two break increases the number of cycles by at most 1, and there exists a two break increasing the number of cycles by 1, and every sorting by two breaks must increase the number of cycles by blocks PQ minus cycle PQ. So, the two break distance between the genomes P and Q is equal to the blocks PQ minus the cycle PQ. Now, we apply an example. We want to know how many genomic reorganization we have between human and mouse. We know that human and mouse genomes can be decomposed into 280 synteny blocks of at least 0.5 million nucleotide times. that the breakpoint graph on these blocks has 35 cycles, and that the two break distance between human and mouse as a consequence is 245. But the problem is that we do not have a unique deterministic answer because there are numerous 245 step scenarios. The true scenario may have more than 245 steps. So this is an estimation in average. And in the next video, we will speak about rearrangement hotspots in the human genome.